Hello class, this is Ms. Martins and we are in Unit 8 Energy. Today's objective is students will be able to analyze potential energy diagrams to determine change in heat, potential energy of reactants and products, and activation energy. Students will also be able to classify diagrams as endothermic or exothermic. So I know this is a mouthful for today, but when I go through the lesson, it'll be more simple than it looks. So for some basics, a reaction will occur given an effective collision. So when we went over rate of reactions previously, you guys understand that a effective collision, effective once again means successful, has to have a correct orientation and enough energy. So let's recall and refresh, do this question first. In order for a chemical reaction to occur, there must always be what? Is it one, particles with proper energy and orientation? Two, reacting particles with a high charge? Three, a bond that breaks in a reactant particle? Or four, a huge gain in potential energy? So take some time, pause the video before you answer the question. If you answered number one, you are correct. Particles with proper energy and orientation. Remember, for an effective collision to occur, it must have proper energy and orientation. What is that energy? So in order for a reaction to occur, particles must collide with enough energy, and that energy is going to be known as the activation energy. We're going to be going into what an activation energy is and why it's important for reaction rates and collisions. A reaction involves either a gain or a loss in energy. A gain in energy is known as an endothermic reaction, whereas a loss in energy is known as an exothermic reaction. So let's go over our P diagram, and then everything that I've been going over is going to make a bit more sense. So this line A here, where it's labeled A, is going to be the reactants. B is going to be the products. Number one is the potential energy of the reactant. And number two is going to be our activation energy. Number three is going to be the heat of reaction. And number four is going to be the potential energy of the products. So understanding the PE diagram is very essential for understanding today's topic. So make sure that you write this slide in your notebook and you're able to decipher which point on the graph represents what vocabulary term on the right. So a gain in or loss in energy. So if I'm going to be adding heat to this beaker, is it going to be gaining energy or is it going to be losing energy? It's going to be gaining energy. And like I said before, the term for a reaction, a chemical reaction gaining energy is going to be called endothermic. Now, if I'm removing heat from this beaker, that's going to be a loss in energy, and that term is referred to as exothermic, an exothermic reaction. We can also look at this in terms of chemical reactions, chemical equations. So we have carbon and oxygen coming together to form carbon monoxide and energy. In our reactants, there's nothing in our reactants, but we see that there's an energy in our products. So that means that our chemical reaction is going to be releasing energy. So there's a loss in energy, and this is going to be an exothermic reaction. With this chemical reaction, we have sulfur and oxygen coming together to form sulfur dioxide. This is a covalent bond. That's how we have the prefixes. Energy is also in the products. It's releasing energy. This reaction is releasing energy. There's a loss in energy. Hence, this is an exothermic reaction. A really quick way to understand or remember the difference between endothermic and exothermic is exothermic has the prefix X, right? Your X is something that you released from your life. If you're going through an exit, you're leaving. So with exothermic, the energy is leaving. There's a loss of energy. That's just a quick way to remember or decipher between endothermic and exothermic. This next example, we have kilojoules in our products. Kilojoules is going to be the units for energy. It's in the product, so we know that we're losing energy. This is going to be an exothermic reaction. And for this reaction, we have our kilojoules in our reactants, 182.6 kilojoules. That is going to be gaining energy, so this is an endothermic reaction. For this reaction, our kilojoules is in our products. There is a loss in energy. This is going to be an exothermic reaction. So now we're moving on to the PE diagram. We're starting off with 20 kilocalories, if you look at the units on our potential energy diagram. 20 kilocalories for our reactants, and our products has about 40 kilocalories. If you're looking at the graph, we have a lower energy in our reactants than we do in our products. So this reaction absorbed energy. There's a gain in energy. Energy of our reactants, energy of our products. There's a gain in energy. Hence, this is an endothermic reaction. It absorbed energy within the reaction. It went from 20 to 40, if you guys can see that. And for this one, our reactants has a lower potential energy than our products. Once again, there's a gain in energy. This is an endothermic reaction. For this one, our products has a higher energy. Our reactants has a higher energy than our products. Therefore, there's a loss in energy, and this is an exothermic reaction. So for endothermic reactions, we're absorbing energy. For exothermic reactions, we're releasing energy. For endothermic reactions, our energy is going to be in the reactants. For exothermic reactions, our energy is going to be in the products. And remember that you can see the energy as joules. So joules is the units for energy. It could be kilojoules, it could be kilocalories, it can be calories. That's how you'll know that's energy. And we went over the potential energy diagrams for each. Remember that if the reactants have a less energy than the products, that is going to be an endothermic reaction. If the products has less energy than the reactants, that's the exothermic reaction. And delta H is going to refer to the change in heat. And for an endothermic reaction, the change in heat is going to be positive, whereas for the exothermic reaction, the change in heat is going to be negative. So let's answer this question together. Feel free to pause the video before moving on. The minimum amount of energy required to start a chemical reaction is called, and we just went over this, this is going to be the activation energy. Which arrow represents the activation energy in the diagram on the right? So this is the diagram here. Which arrow represents the activation energy? It's actually going to be this arrow here, B. So our answer is B. That's the activation energy. And our PE diagram, catalyst. So a catalyst is something that speeds up the reaction. Yesterday I made you watch a video. And they were speaking of rate of reactions. And basically our catalyst is going to be something that you use in order to speed the reaction quicker than it will go. So whether that's adding more heat to the reaction, or for example, the video was about a relationship and they got into a relationship by bumping each other in the hallway. But instead of just running and bumping into each other, if someone had pushed them, the push would be also an example of a catalyst, right? So without a catalyst, an activation energy is really high, but once you add a catalyst, it speeds up the reaction, making the activation energy low. So without a catalyst, let's say the activation energy is about 140 kilojoules. With the catalyst, it could bring the activation energy down to about 100 kilojoules, and this basically speeds up the chemical reaction. So activation energy is the barrier to the reaction, but a catalyst is able to bring down the activation energy in order to have a faster reaction. So this is very important. A lower activation energy equals faster reaction, and what creates a lower activation energy is going to be our catalyst. So what changes when you add a catalyst? The only thing that changes when you add a catalyst is going to be the activation energy. What stays the same is the PE of the reactants, the PE of the products, and the heat of reaction. So that's all for today. I'll need you guys to complete the Google form titled Exit Ticket Potential Energy Diagram Practice Problems. Remember, stay safe. I hope you guys are all doing well. Enjoy your day, and thank you for listening to this lesson.